Hello everyone, my name is Lennard and I'm an application engineer for Rigel Medical. Today's webinar will be on the Multi-Flo Infusion Pump Analyzer by Rigel. It's going to be a presentation with some of the key features, manual mode, automatic mode, also the remote control mode using Rigel Med-eBase, so some of the ways of driving the instrument itself. And accompanying this we'll do some short demonstration videos alongside. So if anyone's got any questions, please save them for the end, and also we can possibly do some one-to-one demo training if anyone wants to look at the Multi-Flo more in depth. We've got the Multi-Flo here today, so if we want to go into that more, we'll save that for the end. So please let me know if there's anything you'd like to go into in more detail. So firstly, a little bit about ourselves at Rigel Medical. We are renowned globally as a designer and manufacturer of reliable, portable and compact biomedical test equipment. Our products ensure that critical medical equipment is safe to use throughout a device's product life cycle. And as metrology specialists for almost 4 decades, our innovative testing solutions have been mitigating risk worldwide in healthcare environments. We've got 2 operating locations, so one is in Peterlee. This is our main manufacturing part of the company, so we're based in the UK. We've also got our US office, which is based in Tampa, Florida, and that's headed up by Paul Fopel. And we've got 7 Rigel authorised global service centres with 40 distribution partners, and that means we cover 110 plus countries worldwide. Okay, so the Rigel Multi-Flo is IEC 60601-2-24 compliant. Got 1, 2 and 4 individual channel configurations. You can test up to 4 infusion devices simultaneously across a range of 10 microlitres up to 1500 millilitres per hour. It's also upgradable, so if you've purchased the 1 channel configuration Multi-Flo, or you're intending to purchase just the single channel and you're not sure if you want to upgrade at a later point, you can do that. It's relatively straightforward procedure. You can always upgrade to 2 or 4 channel configuration at a later point. So it's got instant flow and pressure. We've got a large colour graphic display and presents the data in both numerical and graphical format, but I'll show you this on screen with the demonstration video. It's compatible with all infusion devices thanks to its low flow rate capability and large storage, and results are stored in the internal memory. So a little bit about infusion devices. If anyone missed the seminar on the introduction to infusion devices, there's a little bit about them. So IEC 60601 is the standard for the requirements for the safety of infusion pumps and controllers. So this is the internationally recognised standard. It details the performance and usability requirements. Infusion devices are the most common devices in hospitals. They are often 2 or more per bed, and it's crucial that these devices are performing correctly and accurately, and this is what the 60601 standard aims to cover. So testing should reflect what the manufacturer recommends, ensuring that the equipment is working within its specification and is fit for purpose. And so within service manuals you'll have preventative maintenance schedules. This is what you need to follow for regular testing of infusion devices. There's a variety of methods currently used to test infusion devices and determine their performance accuracy. So from the previous webinar we spoke about scales, barrettes, cylinders, some of the traditional methods used for measuring flow. However, what we can find from that is that it's time consuming, it's awkward to set up, and it's very resourceful to monitor these types of methods. It's purely manually driven, and it's very laborious. So fundamentally the aim is to measure the accuracy of the delivery volume and flow rate over a range of time periods, typically between 10 minutes and 1 hour. However, within manufacturers, you might see testing up to 24 hours. It does vary, but for regular testing, testing in biomedical departments and hospitals, you're typically looking at 10 minutes to 1 hour. Basically, got occlusion and alarm pressures are also to be tested. Bolus delivery must also be tested to maintain the performance of an infusion device, especially with PCA devices where the bolus is self-medicated by the patient. We'll come on to some of these characteristics from bolus and occlusion. So when looking at the accuracy of an infusion device, the system must be looked at as a whole and not just the pump or driver individually, as the inaccuracies within the measuring device need to be added to the accuracy limits of the DUT, the device under test. So we're looking at all the possible uncertainties within the system. It's not just the device on its own. We've got to remember is that the infusion device needs to overcome pressures within circuits, and it's the whole circuit as a whole that needs to be tested, much like in many calibration procedures, that the whole system is to be tested, not just the device on its own. So even though the infusion device itself may only have a small percentage error, taking into account all possible inaccuracies such as the syringe used and also the tubing. So the recommended checks, we've got acceptance testing or reference test, not normally as comprehensive as the regular tests, but you'll often have a quick flow rate or volume check, and also a quick check of the occlusion. So this will always be recommended by the manufacturer. It'll either be in the PM schedule or it'll be part of an acceptance or on receipt test. Then you've got regular testing. This is your scheduled preventative maintenance in accordance with manufacturer recommendation. So your visual door alarms, your flow volume accuracy, occlusion alarms, and bolus/PCA check. So you've got routine testing as well. So you need to do daily checks for damage and fluid aggression, and then electrical safety testing according to the standards, whether it's IEC 60601, 62353, or it could be any others. It could be according to the national codes, such as NFPA 99 in the United States and ASNZS 3551 in Australia and New Zealand. So this depends on the region for electrical safety. But for regular testing, acceptance testing, and routine testing, this will be recommended by the manufacturer what to look out for and what to test performance-wise and measuring for accuracy. So measurement technology, infusion device analyzers, they offer a number of advantages. The user can set up an automated test and the test will run unassisted. This allows the user to move away from the device during testing. It's not like the other methods where you've got to continuously check on the device and there's all sorts of issues that can occur. With this, it runs completely automated. They also provide real-time records of delivery rate and volume. It allows for continuous infusion device testing without constant supervision. They provide continuous spot reading, which can then be graphed to provide quick-to-read on-screen results. And with this, problems and anomalies are easily visible. So what's commonly carried out during a test, if you was to push start, you would get your instantaneous values, your mean values, but then you could switch to the graph to see if you're getting any anomalies throughout the time of the test. So it's worth having that screen up on there to see if anything's gone wrong. Analyzers also provide automation and multi-channel testing, with analyzers having up to 4 independent channels, and they can run simultaneously, and this reduces overall test time whilst maintaining a good degree of accuracy and also minimizing user input and then any errors that could occur. Basically, the measurement technology within the Multi-Flo. The chambers are small, 50 microliters. So how does this work? It calculates flow with very small volume measurements over time. Flow is therefore measured accurately in a short time. Flow rates from 0.1 to 1500 ml per hour with a 1% accuracy after 100 microliters. And the reason for this is the 50 microliter chambers. So we need the two samples to produce accurate rates. Tests can be accurate within minutes. Update rate is 1 Hertz. Flow rates can also be shorter, and PCA bolus testing can be carried out. So this is the volumetric second generation of how we've incorporated this into the Multi-Flo for flow rates. So before going on to testing, it's important to look at the performance and maintenance with infusion pump analyzers. They are susceptible to certain things. You are dealing with fluids which can cause issues with the analyzer itself. So priming is very important. We've got a performance and maintenance manual for the Multi-Flo. You can find that on our website, which goes into a bit more detail. But I think we should go over this just because it can sometimes get overlooked, and it's really important for looking after the instrument and prolonging its life cycle without having to go back for any any repairs, which can be not very cost effective. You get downtime on your instruments, so it's about prolonging the life of your instrument. So we talk about priming and using the micro 90 solution. So here we clear the airline bubbles by running deionized water through the Multi-Flo. So many people use deionized water. You can use distilled water, but really we should be mixing a solution of micro 90 with deionized or distilled water and running that through the Multi-Flo. And the reason for that is that it clears any contamination, any potential for organic growth within the system, and this can have a real effect on the accuracy and performance of the device itself. So we really recommend this. It's not expensive, it's very cheap, it's cleaning solution, and you only need to add a small amount to the fluids. So to carry out the test, use a syringe manually or select a high flow rate on the infusion device. Typically we use a syringe, and then we can prime the device using that, and then I'll show you how to do that on the next few slides. So to prime the system, from the main menu you just select prime, really simple. Setup. Okay, so we connect the pump to the, sorry, that's incorrect. We connect the pump really to the T-piece. So you're going to use a T-piece or 3-port valve for testing. This is really crucial. So you've got your device under test on one, your Multi-Flo on another, and then the priming syringe on the other part of the port. So we'd have our device under test here, our infusion device, but for the first part we're just going to turn this off. And the reason we don't just switch between tubing is this is how we can introduce air or contaminants into the system. So when we're priming, we ideally want this set up where we can switch off using the valve while not having to introduce any new tube into the system. So with this priming syringe through to the infusion device to the collection vessel, that's it, using the priming menu selection. Then after that, so we've done our priming. Also again, it recommends the micro 90. I can't reiterate that really. Again, so the infusion devices, Multi-Flo and connection vessel are then placed on the same surface. Always ensure this. We can now switch the 3-port valve and remove the syringe. And now we're going to do testing with deionized water. You can use distilled water as well. It does say only test, but you can use distilled water. So here we've got the device under test going direct to the collection vessel. We've shut off the flow to the infusion pump, so there's nothing flowing to the collection vessel from the Multi-Flo. And then we can, sorry, as I said, it's shut off from the Multi-Flo. And then we connect the pump directly to the collection vessel with the valve switched off. So The system is then fully primed with no air in the device under test, so we're going to fully prime that until we're seeing no air within the system. And then with this system, we've cleaned the system using the priming. We've got no air in this part of the system. We should have no air in this part of the system. We should be ready to test. But if there is still introduced a little bit of air within the system, before testing, we select a drain test, which is what we're going to do in the example in the video. So we connect the outlet tubing and collection vessel to the outlet of the Multi-Flo. We use the right tubing for the device under test, and we keep the tubing distance as short as possible. And here we see the valve is now just going straight from the device under test to the input of the Multi-Flo and to the collection vessel. And this is just a better representation of how this is carried out. So depending on what you're using, so we've got a volumetric infusion pump. The inlet would go through here via the T-piece or the freeway valve into the inlet, and then the outlet will go straight to the collection vessel. Pretty simple. And with the syringe driver, it's the same setup. Case of manual mode using the Multi-Flo. Measurement of the volume delivered over a period of time. This is how we carry out the flow rate test. So we go to test, manual mode. We're in here, we select the green encoder button, so we're on 1 if we're using the first channel. And then we can change all our parameters within the flow test setup. So once we're happy with our parameters, we select this function key here, and then we're ready to test. It's ready. You press the green button again on the Multi-Flo, and then it's ready to measure. But it won't actually carry out a test. It won't start measuring flow or elapsing any time until the infusion device begins to operate. And then once it begins to operate, it will measure, and the countdown will commence. And then you can also switch from these numerical values using the F2 or the second function key to go to the graph and see the on-screen analysis. So we've got manual mode occlusion test. What is it? It's the measurement of the maximum pressure in the circuit when an occlusion is simulated by the Multi-Flo for patient safety. So if you're running a flow rate from the infusion device, the Multi-Flo is just producing a back pressure and simulating an occlusion in that circuit. There are 2 types of occlusion systems: stop manual and stop and reverse. So once the infusion device has either stopped or stopped and reversed, then it will be displayed on screen, and you can capture that using the green button on screen. So you'll actually capture the value, or it's stopped and reversed. So it will automatically reverse the pressure, and it will be captured within the Multi-Flo automatically. So there's two different types of systems. We've got bolus, which is a fixed volume of extra delivery to the patient. Pain treatment. So the patient typically delivers this self-medicated. A baseline flow rate needs to run. So we've got this baseline flow here, and then we've got these boluses which are being administered. The Multi-Flo will measure these boluses perfused onto the baseline current flow. So it's important to note when you're setting this up, the basal flow rate must be 5 times less than the bolus. So the flow of the bolus needs to be at least 5 times the current flow. So for this, the bolus volumes would typically be 100 mil per hour or more. And this gives you some more example of how this is set up. Once you actually go into the test, you've got these volumes on the screen, and you'll also have the numerical details. And then we've got automatic mode. So rather than go through automatic mode using the presentation. We'll first do a short video on the manual mode, so actually during that during the demo, and then also I'll run on to automatic mode preceding that. We're now ready for a manual test. We've shut off the IV giving set and plug it into the infusion device. Okay, so that's clicked in. We'll lock that in and then we'll run to test, and we're going to use manual test, which is F4. Now the parameters aren't too clear on here, but we're just going to leave the settings as they are. We've got volume to be infused 20 ml, but I'll show that on the screen a bit closer so it's more clear. We always push start first on the infusion device analyzer, and then we select run on the infusion device itself. The Multi-Flo will always wait for any volume to be infused before carrying out a measurement. Okay, so now we're running. We've got the instant flow rate shown on screen, not very clear, but it's the second from bottom, and then the mean mil per hour. So the reason that's low is because it's not actually reached the full stage. There's that initial trumpet curve whereby the pressure has to overcome pressure in the circuit before reaching, and that shows in this diagram here. So we've got the flow rate is now achieved, and the mean flow rate will gradually come up. But we're measuring volume here, so 20 mils. Volume to be infused is 20 mil. So we're just going to run through this test until it's complete. We didn't actually change the time, so we'll likely finish before the time's elapsed on the Multi-Flo. Okay, so we skip through to a few minutes in, and we can see now that the flow rate is starting to drift off, and these little peaks you can see, that's that peristaltic action from a volumetric pump. But over the 3 or 4 minute range, it will be accurate. At the moment we're just measuring the total volume infused, and that's common in PM schedules. You're just measuring the total volume over a certain time period. Okay, we finished early, so we've got a data error, but we can always just stop it early and save those results. So that's stopped. We can now save it under an asset ID using the encoder. Just give it a random number. That's saved. Select OK. And now we can go and view that data to see how accurate the infusion device volume is for this test. Okay, that's the one. Select results, view. 20.001, so I think for the Lennard SE it's a 3% error, so well within specification. It also gives you the graphical representation, so the volume is achieved at the point at the end before we've stopped the test. That's a manual mode test. Okay, so to perform an automatic test you need to have a test sequence. You can either use one that's on there or create your own. So today we're going to create our own test sequence, just a short one, just show you how it's done. So we click new, key in an asset, new test sequence name, so we'll call it test 1. We're using the USB keyboard, it's now created. F3 is to edit, function key F3, and we can insert new tests. So we'll insert a flow rate test. Again, we'll use similar parameters, but we'll set the duration to a little bit less, so we'll set this to 6 minutes, 30 seconds for demonstration purposes. We're measuring volume, see a limit type. So the first test, say if we wanted to do 2 volume tests, we're going to set 20 first, and the Alaris SE has a 3% error for the PM. Okay, so that's one. We'll insert another flow rate test. In this case, we'll do a 40 mil volume test. So a similar test, but just increasing the volume limits. So we can change that also to flow if we want. We've got average flow and instant flow, but for this purpose we're going to do a volume test. Okay, so we're happy with that. We've now got two tests in here. Okay, so let's add another test. Let's add an inclusion test. We can edit the values on here, so the upper and lower pressure limits. Just for demonstration purposes, we'll put arbitrary values, 450 for the upper and 350 for the lower. Okay. Okay, we've got the inclusion test in a minute. That's okay. We'll save that. That's the test now saved. Got a test sequence. We can select perform test. Key in our asset ID number. Use the keyboard again, Alaris SE2, let's call it. Just save it under that asset ID. And we're going to, for the protocol, we need to select the test sequence we've just made. So we found that, test 1. We go to make. And we select model and serial number. Okay, ready to perform the automatic test. So we'll quickly speed through this. We don't need to see all the tests running through the full time scale. It's just to really demonstrate how the tests are saved once the automatic test procedure is finished. Okay, so we're just waiting for the Alaris test to start. Press run on the Alaris SE. Got 400 ml per hour with a 20 ml volume to be infused for the first one, and then once that one's finished, there's an occlusion test, and then we'll do a 40 ml fusion to be in test flow rate test for the second automatic test. Okay, so we've got that initial undershoot for the mean flow, so we can see that, and then there's a slight overshoot before settling down. So if we skip quickly through the tests, so we've got flow rate done. We'll go to occlusion. We won't actually do the occlusion test, we'll just end that and go through to the next flow rate test. We'll run through for the 40 ml infusion to be infused, and then we can wait for that test to complete. We've already got the volume is complete, but we'll just wait for the time to elapse. So that's all the 3 tests done, except we've skipped the infusion, and that's now saved and complete. We've got to click save, which is the second function button, and then we can go and access the results under that asset ID name. So it's really easy to set up an automatic test with a Multi-Flo. And if you want to set up your own test sequences, again, that's very easy, but it's even easier if you're using Rigel Med-eBase. So, but always keeping, if you've got Med-eBase or you need to get any test sequences, just contact us at Rigel. We've got some available. We're quite happy to produce any test sequences you might you might need. So always contact us if you want us to provide anything. Okay, so I'll just cycle through these results to try and find the one we're after. Is it that one? No, it's RSSE2, I think. Quite a few asset IDs on here, so it takes a bit of time cycling through. See where the benefits of Med-eBase come in. Okay, so we've got our two flow rate tests. Okay, we've got our volume, 19.99. We've got the graph showing the flow rate. So well within specification for this thing, and even for the volume on there. I think we kept the flow rate going for the 40ml one, just slightly at the end there, so that might be why it's reading over. We'll have to redo that test, but it's still within specification, even after the time's elapsed. That's automatic mode. So on to Med-eBase. With Med-eBase you can produce test sequences and individual tests, and this helps to reduce setup time. And I'll show you this in a quick demonstration video we'll do next of how it's much more beneficial to drive it in remote control mode. It's a lot more time saving, so if you've got a lot of devices to test, it's really advantageous. It's got flow and volume, occlusion, PCA bolus again. Got real-time graphical and numerical results on the PC. You can do data analysis with this. You can zoom in on the actual flow rates. You can look at percentage error limits and the expected values shown, and the asset ID is then saved into the Med-eBase asset management system. You can also view results and print certificates, and you've got instantaneous results on screen, which helps reduce the test time. So I'll just quickly show that demonstration video. Okay, so it's really simple to set up the Multi-Flo for remote control mode. We connect the USB from the PC to the side of the Multi-Flo USB-C port, and then we select the remote control mode here, and now that's ready to be controlled by the PC. Okay, so from tools we select the download icon, make sure that the Multi-Flo is selected, and then we select the remote mode to connect to the COM port. Add a flow test first, show how to do that. We've got duration type, so it can either be volume based, time based, but for this presentation we'll just do time based like we did before, so set a similar duration. And we can set the flow rate, or we can select the limits. So we've got multiple parameters within Med-eBase where you can change these, and it's obviously clearly a lot easier than trying to do it on screen with the encoder. Okay, so we'll set the similar limits. Set the flow rate to 400ml per hour. Expected volume 40ml. We can start the test. So you need to select an infusion. We'll select a run of the asset IDs number, so you need to create an asset ID first before you do this test if you want to save the results to that specific asset ID. And now the test has started, so we need to go back to the infusion device and start the pump. Now the time's elapsing, and with this you've got a similar display to the Multi-Flo, but it goes a little bit more in depth. So you've got all these graphs, but you can analyse the expected limits, and also the upper and lower limits from whatever you've set your limit type to. And also you can select individual points at times, and you can get those values at that specific time. So it's a way of really extracting the data and playing around with it as much as you need to, really. You can also right click to inspect different parts of the graph. So really useful piece of software when it comes to the Multi-Flo. So let's do an average flow rate test in Med-eBase. Looking at this, we're changing the error now from volume to average flow. Still got those same upper and lower limits, but with this we can have a look at how the infusion device performs over time. So if the flow is accurate over 2.5 minutes, say, so we're going to run this for 2.5 minutes, and then once that time's elapsed, you can have a look at how the mean flow rate starts to level out and becomes accurate. So you can use it for analysis and looking at the on-screen data in real time. So I'll just skip through. Okay, so we can see that the mean flow is coming within the limits. So if I just skip through some of that and speed it up towards the end. And now that data is recorded, we can have a look in the results under the asset ID number. So if we go to search using Med-eBase, top one there, so it's saved under asset ID 10 for the last test that was done, which was this one. You can view the results and see all those different waveforms that were saved under that asset ID. So we're looking at the average flow rate. We can zoom in and take a real good look at the data that we've got. So we can zoom in there a little bit better and see the average flow over time. If we want to have a look at a bit more in-depth analysis. And as well, with the numerical data and the report, you can print this off into a PDF format. So print certificate, again, you can have a look at a quick overview of all the graphs we've got. And it's simple as that. We'll save this one as a test, and that's it. So that brings us to the summary of this presentation. So a bit more of the key features. We understand there's a large test capacity per channel. It saves time with accurate instantaneous flow measurements across multiple devices. We know that it meets manufacturers' test requirements by creating or sharing test protocols for different models or applications. Got fully traceable results, storage and automatic data capture, and this reduces the time and manual data errors. And then also seen today the increased throughput with Med-eBase with its remote control function. Also got the improved data analysis with high resolution storage. It provides full peace of mind with compliance to IEC 60601-2-24. We've also seen the graphic display with clear data viewing as well. So, and in addition to that, the flexible purchase with optional future upgrades. So we've gone through, tried to go through some of the tests as quickly as possible today, the manual and automatic mode. If there's anything I've missed, please contact me lewisl@rigelmedical.com, or just let me know in the chat box, and I'll have your email, and I'll be able to contact you further to this webinar today. So that brings us to the end. I mean, there's some of the specifications here, but I won't go into that today. It just reiterates some of the key aspects of the Multi-Flo. And that brings us to the end of this presentation. If anyone's got any questions, please fire them into the question box below. If you'd like a copy of this presentation, I've made that PDF available to you in the handout section. Thank you all again for viewing the webinar. I'll just go through some of your questions now, so please fire away. Okay, thank you.